Welcome back, everyone. This is Dr. Galenstein, and here we are with the RStudio demo for lecture number 5. So in this lecture, we're looking at omitted variable bias. And here in R, I just want to demo a couple of things for how to kind of recognize and test for omitted variable bias. For this lecture, we're going to need another package that you probably don't have. It's called the LM test, so go ahead and install that. I won't install it now because I already have it. All right, I'm going to import the data. We've seen that before. And then let's just go ahead and begin just kind of conceptually. So let's say we have a regression model. Okay, actually I'll just write it out. Let's say we have a regression model, wage regressed on education and experience. And let's say for now that that is the true model, so to speak. When I say the true model, what I mean is that this is the model that explains wages. Okay, so let's just say this is our model. And let's say that this is the true model. All right. And we can even run this model. In fact, okay, I will go back and change the order of my notes here. Let's say we could even run this model. I'll call it the true model. All right, so it's wage regressed on education and experience. So I'll just go ahead and run that, produce the estimates here. Okay. So now if that's the true model, then education and experience are both important. They're both relevant factors for explaining or understanding wage. And when we talk about omitted variable bias, what we're talking about is the implications of excluding one of the relevant variables. So what I've said here is that wage regressed on education and experience, I'm saying that that is the quote, the real model. That means education and experience are both relevant. They're both important variables. We need to include them in order for our model to be the true model of wages. So then what happens if we exclude a relevant variable? What happens if we exclude a relevant variable? So let's go ahead and exclude experience and see what happens. Okay, so if we exclude experience, we can actually notice that the coefficient is different on education. If we exclude experience, the coefficient on education is 0.54. If we include experience, then the coefficient on education is 0.65. The coefficient on education changes depending on whether or not we include experience. The reason it changes is because of what we call omitted variable bias. What happens when we exclude a variable that belongs in the model is that other variables that are correlated with it, the coefficients on those other variables will be biased. There will be a bias in the estimate of those other coefficients in the model. And we can see this playing out. We can see that the coefficient estimate for the education variable changes when we don't have experience in the model. Well, the reason for that is because there is an omitted variable bias in the education coefficient when experience is not included. And in fact, we can see that it's a downward bias. The value of the education variable is smaller when experience is not included. There's a downward bias on that coefficient. This is what we call omitted variable bias. Now, if this were the true situation, let's say this really was the true model, it would be easy enough to fix. We have data on experience, so we could fix the omitted variable bias just by including the experience variable. But in real life, we typically have omitted variable bias because there are variables that we don't have in the data set, so we cannot just include them. This is a major problem for econometrics. In fact, this is the problem that we are devoted to trying to solve later in this class. In part 2 of the class, we will learn a bunch of techniques for how to solve the problem of omitted variable bias. But for right now, we just need to acknowledge that omitted variable bias is a major problem. And in fact, what we've seen so far is we actually have a possible way of detecting if we have omitted variable bias. If you have a variable in your model, let's say in this case education, and then the coefficient on that variable changes when you include a new variable or exclude an existing variable, if it changes, that gives us an indication that we might have omitted variable bias. We can notice it here. Okay, so that's omitted variable bias conceptually. Now, how do we test for it? Now, in reality, omitted variable bias cannot be formally tested for, at least not universally. We don't know for sure if we have omitted variable bias. We have to use our intuition. We have to use our intuition, our knowledge of economics, our knowledge of economic theory to be able to intuitively specify or conceptually specify what we think the correct model is. And when we have in our minds what the correct model is, if one of those variables are excluded, then we can intuit that there is omitted variable bias. Okay, so really the most important thing we need to use is our knowledge of economics in order to understand if there's omitted variable bias. Practically speaking, almost always you will have omitted variable bias. So it's better to assume that you have omitted variable bias than it is to assume that you do not. And later in the class we'll learn a bunch of techniques for what to do if we do have omitted variable bias and how to solve it. Okay. But there is one formal test that we can use that is at least somewhat helpful to testing and understanding if we have omitted variable bias, and that test is the Ramsey reset test. So to run that test, we'll need the LM test library. So I'll just inform R that we would like to use that library. Okay, so first we will do it by hand. When I say by hand, I mean we're going to run a bunch of regressions and a bunch of lines of code for us to perform the test on our own. And then later, we'll just use the R command for the test. Okay. All right, so we do it by hand once in the lecture just so we understand what it is. All right, so here, let's say this is our model. We've got education, experience, and female in the model. All right, so here's our model. Here's our results. Now, the Ramsey reset test, the way that it works is it says, well, maybe we have omitted variables, and maybe those omitted variables are some sort of polynomial, some sort of squared or cubed value of variables that are included in the model. So, and so maybe we're missing, maybe we're supposed to have education squared or experience squared or something in the regression. Well, one way of getting at that is to use this test. So here's how it works. What we're going to do is we're going to create the predicted value from model 3. To generate the predicted value, we just use the predict command and we tell it the model that we want it to predict. So that's model 3. So use the predict command, put it in model 3. And then we want to take that predicted value and we want to make it a variable in our data set. So we'll call that variable y hat, and we want that variable to be inside of the wages data set. So that's what's written here, and so we'll produce that. We can even take a look at it if we want. Here it is, y hat, the predicted value from that model 3. Predicted value for all the different variables, or all the different observations. Okay, and then what we do is we create a squared term, a cubed term, and a to the 4th term. Okay, so we're just going to create new variables. So we can go and look at those variables if we want. So we got y hat squared, y hat cubed, and y hat to the 4th. Okay, and then what we're going to do is we're going to run a regression. I'm going to call this model3.reset. That's just the name I'm giving it, just indicating that I want to use this model to do the reset test. And I'll include y hat squared, y hat cubed, and y hat to the 4th. So the same model, but including those additional variables. All right, so I'm going to run that model. Okay, and then I'll use a linear hypothesis test to check for the joint significance of those three variables. If they are jointly significant, that would give us evidence of omitted variable bias. So let's run that test. We find the hypothesis here, And then here we have the p-value. We can see that it is statistically significant. That would indicate to us evidence of omitted variable bias. Okay, now if I just want to use the R command for the test, here's the R command, reset test, model 3. We tell it the power. That means, do we want our y hat raised to the second power, the third power, the fourth power? So equals 4, that means I want it raised to the second, third, and the fourth. All right, so we just run it. It's just the formal version of this. We get a p-value. The p-value is very small. That is consistent with rejecting the null hypothesis. And so, again, that gives us evidence that there is omitted variable bias. Okay, great. There you go. Hope you enjoyed the lecture, and I'll see you next time.